Hello guys, so in this video we're gonna prove the associativity or the associative property for the XOR gate. Then it will be easier for you in your homework to do the proof for XNOR, okay? So basically we wanna prove that X XOR Y, then the result XORed with Z is exactly equal to the Y XOR Z, then the result is XORed with X. That's what we want to prove. Okay? You can do that in a very easy way using truth table, and I will leave that to you. But basically what you're going to do is that you will have a column for X, a column for Y, a column for Z, then a column for X XOR Y, and a column for X XOR Y, then the result XORed with Z. So we will just, XOR that column with that column. Then you have another column, which is Y XOR Z. Then the final column should be is X XOR Y XOR Z. Okay? Which is XOR of that column here and that column. And you should find that this column is equal to that column. I mean, the first value here is equal to the first value here, until the 8th value, because we have 3 variables. So we have 8 combinations. And that's what we basically will do here in the analytical proof. So if we did it with using truth table, why we should do it using analytically? Because basically I want you to train a lot on the analytical, simplification or analytical Boolean algebra, because this is a basic skill that you should learn from out of this course. Okay, beside of course the truth table. Okay, so let's do that. What we basically will do in the analytical proof, we're gonna do something similar to the truth table. In the truth table, we end up with 2 columns. One is X XOR Y, then the result XORed with Z. Another column which is Y XOR Z, and its result is XORed with X. And we prove the 2 columns are similar. So basically here we have left-hand side and right-hand side. Okay, so we will simplify analytically the left-hand side, then simplify the right-hand side, and we should see that the final simplified version of both are just equal. Okay, so let's start by the left-hand side here. Okay, X XOR Y XOR Z. So this is basically, okay, just first simplify XOR Y, which is X Y bar plus X bar Y. Then this will be XORed with Z. Okay. Now you have another XOR. Okay, the 2 terms now. One is called Z. The other term, just to consider it as one variable as well. Okay, just to deal with it as one variable. So we're gonna take it in the first term, we're gonna take it as it is, ended with the inverter or the complement of the second term. Then in the second term, we're gonna complement the first term, which is the bracket. Then end it with Z. Okay. Now distribute the Z bar over that bracket here. So this will give us X Y bar Z bar plus X bar Y Z bar. Then plus we cannot distribute Z over that bracket because it has an inverter, it has a complement. So apply De Morgan's first, then do that. So let's apply De Morgan's. So De Morgan's will invert this and or into and you have the complement of the first term ended with the complement of the second term. So X Y bar complement, X bar Y complement, then Z. These terms will be the same, no change in them. And here again, apply De Morgan's. Okay, so this one will give us X bar, X or Y, bar will go with the bar, the complement will cancel the complement, so we will end up with with just y. And this guy here will give us x bar will be x, then y bar, then z. Continue. This same as well. Then let's distribute the z over one of these brackets, whatever you want. So let's start by the first one. So this will give us x bar z plus yz. Then the second as it is. This or this. Then x bar zx plus. I'm now distributing the x and also the y bar over that first bracket. So then x, y, z, and I'm writing them in order all the time, except here, I just forgot. Then x bar, z, y bar, plus y bar, z. And before we continue, we should look at these 4 terms here, because some of them are just zeros. Like for example, this guy here is 0 because you are multiplying or ending y and y bar, so they will cancel each other. You know that x bar is 0 all the time. What else should be cancelled? This one also should be cancelled because you multiply x and x bar, which is also 0. So finally, we will end up with 4 terms here. Let's write them now. X, y bar, z bar, plus x bar, y, z bar, plus x, y, z, plus x bar, y, x bar, z, y bar. Let's check if we are right. I'm just checking according to my notes here. So this guy is right, this guy is right, right. Okay, we are good. Okay. Now let's go do the right hand side, okay, which is x XOR the result of the XORing of y and z. So this is basically equal to, I'm gonna just do the same, but now with y and z. So first term as it is, XOR y z bar plus y bar z, okay, equal to, now again, second term is just one term, consider it as just one Boolean variable. So first term as it is, and the second term will be complemented, or first term complemented, second term as it is. This is the definition of the XOR. Okay, then we continue further here. We can't, distribute x over that bracket because it's complemented. So we simplify it first using De Morgan's theorem. So this will be y z bar, the total is barred. Then y bar z, total is barred. But we can distribute the x bar over the bracket. So this will be x bar y z bar plus x bar y bar z. Okay. Okay. This guy will be y bar plus z. This will be y plus z bar plus x bar y z bar plus x bar y bar z. So let's now distribute the x over the bracket. So this will be x y bar plus x z y plus z bar, and these are not changing. Then we distribute y over the 2 terms of the bracket. So this will be x y bar y plus x y z, just writing them in order. Then we distribute the z bar over the bracket as well. So this will be x y bar z bar plus x z z bar. Then the last 2 terms again with no change. Now, before we continue again, we will have something like this step here. Something will be 0. Some terms will be zeros, like the first term, because y bar is 0. And here also the fourth term is also 0 because z bar is 0. Now, these are the last term, x, y, z, plus x, y bar, z bar, plus the last 2 terms, which is x bar, y, z bar, plus x bar, y bar, z. We can't simplify more. One may say, how do you know that we can simplify more? We're gonna prove this in our next chapter using Karnoff map. We're gonna see using Karnoff maps that we cannot go beyond that simplification. Okay. Okay, now let's compare now what we have here. Let's compare that guy with that guy here. Okay, let's take one term from the left hand side and search for it in the right hand side. So x, y bar, z bar. Yeah, it's here. So this guy and this guy are there. Okay. X bar, y, z bar. X bar, y, z bar. Yes, it is here also. X, y, z, x, y, z. And finally, x bar, z, y bar. I just make the order. So let's write this as following. Of course, they are the same. So x, y bar, z. To make it perfect for you, although it's still right. X, y bar, z. Yes, and here is x, y bar, z, x, y bar, z. With 4 marks. Okay, so now since 1 and 2 are equal, then we had proved the associative property of the XOR gate. And you can do exactly the same to prove the XNOR. Okay, and this is your homework basically. Your homework is to prove that prove the associative property for XNOR using truth table and also using the analytical proof. So thank you very much and good luck in that homework. Bye.